drift of electron and origin of velocity. Drift velocity is the coverage velocity by which electrons are drifted towards the positive end under the influence of the electric field. In the presence of electric field, when electrons drift, they suffer collision with the heavy fixed ions and emerge with the same speed but in random directions. Therefore, for all the electrons, the average velocity will be zero as their direction is random. Consider now the situation when an electric field is present. A force will be experienced by electrons in the direction opposite to the direction of electric field, and electron starts accelerating by A is equal to minus EE by m. Minus sign shows that direction is opposite to the direction of electric field. Let us consider the ith electron at a given time t. This electron would have had its last collision sometime before t, and let ti be the time elapsed after its last collision. If vi was its velocity immediately after the last collision, then its velocity at time t can be determined by using the formula v is equal to u plus at. The average velocity of the electron at time t is the average of all the vj's. The collision of electron do not occur at regular intervals but at random times. The average time between successive collisions is denoted by tau, but some electrons spend more time than tau and some less than tau. The average value of time, tau between two successive collisions, is known as relaxation time. By averaging over n electrons, we get average velocity Vd. It tells us that the electrons move with an average velocity, which is independent of time, although electrons are accelerated. This velocity is called drift velocity. It may be noted that in the presence of a magnetic field, the drift velocity is reduced and the direction is no longer along the electric field. It may also be noted that the drift velocity is in the order of millimeters per second in contrast to the speeds of the electrons themselves, which are on the order of a million meters per second. Even the electron speed is only a fraction of speed of electricity, which is 300 million meters per second. When electric field is applied across the ends of the conductor, electron starts drifting with drift velocity. On substituting the value of the displacement velocity in the equation and cancelling out the common terms, we get the following result. Also, current I is related with the current density J as shown. Now on putting the value of I in the equation and after simplifying it, we get the following result. The vector j is parallel to E and hence the equation is written in the vector form as shown. When conductivity sigma is taken from the Ohm's law, then we get the result as shown. In most cases, the electron drift speed is estimated to be only a few millimeters per second for currents in the range of a few amperes. Now, we will see how current is established almost the instant a circuit is closed. In first case, we observe that there are very few electrons, so when circuit is closed, the circuit is not completed. Whereas in second case, electric field is established throughout the circuit almost instantly, causing every electron to drift. For establishment of current, electrons need not to reach from one end to the other end of the conductor. The electron drift arises due to the force experienced by electrons in the electric field inside the conductor, but the electrons acquire a steady average drift speed. Each free electron does accelerate, increasing the drift speed until it collides with a positive ions of the metal. It loses the drift speed after collision, but starts to accelerate and increase its drift speed again and so on. On average, therefore, electrons acquire only a drift speed. The electron drift is so small and the electron charge is also small, but we can get large amount of current in conductor due to enormous electron number density. When electrons drift in a metal from lower to higher potential, it doesn't mean that all the free electrons are moving in same direction, but it is superposition of drift velocity over the large random velocities of electron. Now a question arises that the paths of electrons is straight line between successive collisions with the positive ions of the metal. The answer is that in the absence of electric field, the paths are straight lines. In the presence of electric field, the paths are in general curved. Conductivity arises due to the charge carriers. Mobility is the quantity or magnitude of drift velocity per unit electric field. The SI unit of mobility is meter squared per volt second. Mobility is a positive quantity. By using formula of drift velocity, we get mobility, where tau is average collision time for electrons.